very beautiful session and the last one for the thermodynamics. So this session is all about evaluating your understanding about the subject, that is Menti quiz. Have you guys appeared for the Menti quiz before? Those who are coming for the Menti quiz for the first time, this is like the quiz only. There are 12 questions I have brought, simple yet important conceptual questions. Then the first thing you need to do is go to www.menti.com, open this website on your device and use the code which is given, mentioned here, 23458919. Please use the code, open menti.com and then use this code 23458919 to enter into the Menti quiz. All right. So first of all, please do let me know if I'm audible and visible to everyone. Can you guys hear me properly? Do let me know through the comment section. Yes. Am I audible and visible to all of you? This is Chandrashekhar welcoming you all to the India's largest, the best and your favorite live learning platform, that is BYJU'S Exam Prep, the most comprehensive preparation app for all your exams. So the theoretical portion as well as some numericals practice had already been done for thermodynamics. Then it is the time to evaluate your understanding, to evaluate your performance. So take part in the quiz with your full enthusiasm, with your full dedication, and share the link of the session to everyone else in the friend circle so that more and more people can join the quiz. And you will be getting the marks based on your accuracy, at the same time based on your time management. The one who will give the correct answer and fastest will be getting the maximum score. So let us see how much score you guys are getting in the session. All right. So please do join the menti.com and use the code 23458919 so that we can start our session. Are you all ready? Please do write in the comment section. And you are not supposed to write the answer for the question in the comment box. You have to select the correct option as per your understanding through the Menti quiz only. The answers written in the comment section will not give you any score. All right? Yes. Shall we start? Ready? So keep your notebook, pen and calculator handy, because there might be some numerical questions, there might be some theoretical questions as well. So it will be going to help you to boost up your confidence. And after this thermodynamics, the beautiful subject strength of materials will be going to be started at the same time on the same platform taken by Dheeraj Sir. All right. So this is my last session for the thermodynamics, and you will be having the session or the series for strength of materials, one of the beautiful subject, one of the important and basic subject for the mechanical engineering students. So shall we start? I'm not able to see your comments. So I hope you have joined the menti.com using the code. So let us show you the first question. And there will be a timer also associated with each and every question. So you have to read the question carefully and fast, as well as you have to select the answer within the limited time frame. So minimum I am giving you 60 seconds. That is more than sufficient, but you should be very fast and accurate. Accordingly, you will be given the score. All right. So let us start with the first question. Yes. So those who are coming here for the first time, do join menti.com and use the code 23458919. The first question is on the screen and the timer has also started. 60 seconds I had given you. The ideal gas law is valid for, there are 4 options on the screen below. Option A, inert gases. Option B, gases at high pressure and high temperature. Gases at low pressure and low temperature. And gases at low pressure and high temperature. Yes, quickly, 30 seconds you are having. It is going to be very important as well as very interesting session for all of you. So please take part in the session. Yes. 20 more seconds to go. The ideal gas law is valid for. Your time is about to end. Time is up. So let us see how many of you have participated and how many of you have given the correct answer. Yes. Can you guys hear me? Please do write in the comment section. Those who are watching me live, I can see so many students being present there. Those who are present, please give me thumbs up to tell me that you are fully charged up. You are physically, mentally, as well as emotionally present to the session. The first question, the ideal gas law. If we talk about the ideal gas law, what is the ideal gas law? Ideal gas law is PV is equal to MRT. That is the ideal gas equation. PV is equal to MRT is the ideal gas equation. And this equation is valid for the gases where the molecular size and intermolecular forces of attraction becomes insignificant. That is at low density. The gases at low density behaves as an ideal gas. And when the density of the gas is very low, when the density is very less, it means the molecular size will become insignificant as well as the molecules are away from each other. So the intermolecular forces becomes insignificant. So at low pressure and at high temperature. At high temperature, the density is low as well as at low pressure, the density is low. So option D is the correct answer. Option D is the correct answer. Let us have. So nobody has participated. Yes, Ranbir, isn't it mentioned on the screen? The code is 2345, Ranbir, 23458919. This is the code. Those who are attending the Menti quiz for the first time, we will be having these type of sessions because that will calculate your response period also. That will help you to improve your response period as well as the accuracy. So these sessions are, because in examination, 2 things are very, very important. In competitive examination, one is your accuracy and at the same time, your time management, how fast you respond to the correct answer, it also matters. And that is why this quiz is designed in such a way to evaluate your performance based on these 2 parameters. All right. So those who are here for the first time, do open menti.com and use the code to be part of this quiz. The code is 23458919. All right. Others also, those who are here, please let me know if anybody is having any difficulty in opening this quiz. Do let me know. Shall we move to the next question? Shall we move to the next one? Is the first question clear to everyone? The option D is the correct answer. The gas behaves as an ideal gas at low density, which can happen only in the presence of low pressure and high temperature. All right. So the molecular forces of attraction as well as the molecular size becomes insignificant. That is how That is when the gas can be treated as an ideal gas or the gas follows the ideal gas law. Let us move to the next one. Yes, question number 2. Yes, so many students. Now people have joined. Good, good. Yes, those who are facing the problem in joining the session, the Menti quiz, open the menti.com in your device and use the code 23458919. So shall we move to the next question? Question number 2. Shall we move to the question number 2? Ready? Yes, the next question on the screen. The second question on the screen. All of those who are watching me live, please join the menti.com and use the code. Yes, the timer has already been started. The time given is 1 minute and 30 seconds. A Carnot refrigerator operating between -1 degree Celsius and 33 degrees Celsius has a cooling capacity of 1.6 kilowatt. The power consumed by the refrigerator is very simple question. We have already discussed about the refrigerator, how it works. So quickly select your answer. Quickly select your answer. Thirty seconds are still there to select your option. Quickly get your answer. Keep your notebook and calculator handy. You might be required calculator. 15 more seconds to go. Your time is up. Oh my God. Nobody had given the correct answer. No one had given the right answer. The correct answer was option C, that is 200 watt. Look, it is a Carnot refrigerator. It is a Carnot refrigerator. It means a reversible refrigerator. Operating between -1 degree Celsius, -1 degree Celsius, that is the source temperature. Then there is a refrigerator, and this is Q1, and this is 33 degrees Celsius. It is heat work consuming device. So this is Q2. Now, the refrigerator operating between -1 and 33 degrees Celsius has a cooling capacity of 1.6 kilowatt. Do you agree Q2 is given as 1.6 kilowatt? Q2 is given as 1.6 kilowatt, right? The power consumed by the refrigerator, W, need to be calculated. The power consumed need to be calculated. Now, can we say COP for reversible refrigerator? There are two formulas for COP. One is the desired effect. This is the desired effect. So Q2 by W, and that can be written in terms of temperature limits, that is T2 upon T1 minus T2, isn't it? This is T1, this is T2. From here we can find out the value of W. Q2 is 1.6 divided by work consumed is equal to, what is T1? That is, sorry, T2. T2 is 272, isn't it? Upon T1 minus T2. Didn't I tell you that whenever we are talking about the temperature difference, then no need to convert it into Kelvin. So 33 minus -1, that will be 34, will be the temperature difference. Solve for W. W will be equal to 1.6 into 34 upon 272. That will be kilowatt. If you solve this, then you will get 0.2 kilowatt, isn't it? And 0.2 kilowatt is nothing but 200 watt. Option C is the right answer. So those who are here for the first time, please do join menti.com and use the code 23458919 to be part of the Menti quiz. All right, I want more and more people to join. Then only it will be fun learning the basics, learning the fundamentals of the subject. This is the last session for the thermodynamics, and the next session, next subject will be strength of material. So we are helping you out in every possible way to improve your performance in your GATE 2023 examination. You guys are watching me live through the series which is for GATE 2023 aspirants. All right, so let us see the leaderboard. Nobody had given the right answer. Still, let us see. Let us see. Nobody had got the correct answer. Ranbir, Varun, Mif. This is the leaderboard. Okay, so good luck for the next question. Shall we move to the next one? Do join menti.com and use the code 23458919 to be part of the quiz. Yes. Question number 3. Shall I show you question number 3? Ready with your calculator, pen and notebook? Let us start the countdown for question number 3. Yes, get ready. The question is very simple. On TS diagram, the slope of the constant volume line for an ideal gas. The options are written in the bottom of the screen. Option A is less than constant pressure line. Option B is more than constant pressure line. Option C is less than constant enthalpy line. Option D is equal to that of constant enthalpy line. Only 1 minute was provided to you for this question. So select your answer. Yes. I hope you know the answer. I have already discussed about constant volume, constant pressure lines on TS diagram. I have also talked about PV curve also. Five more seconds to go. Those who have not still selected, please select your answer. Only one student had got the right answer. You need to work hard to crack the GATE examination. That is the hint to you that you should prepare very well for your GATE 2023 examination. The correct answer is, look, on TS diagram, the slope of constant volume dt by ds for constant volume is given by T by CV. It is positive. On TS diagram, the slopes are positive. And the slope of constant pressure line is given by T by Cp. That is also positive. So if you know how to draw constant pressure line and constant volume line, these will be drawn like this. Like this. So if you see, if you divide these two, so dt by ds, slope of constant volume, divide by slope of constant pressure line, then it will be Cp by Cv, and that is gamma, which is greater than 1. So that is why the constant volume line will be having more slope compared to constant pressure line on TS diagram. I hope it is clear to everyone, isn't it? So the correct answer to the question is, option B. And let us have the leaderboard. Who was the one who had given the correct answer? Nora Fatehi. Well done, well done. You have opened your account and your score is 809. You have given the correct answer and you are the fastest one. So ask your friends to join the session so that more and more people can join, and we will be having the fun learning the basics or revising the concept of the subject, beautiful subject, thermodynamics. Shall we move to the next one? So do join, those who are here now, those who have joined lately, do join. Do open menti.com and use the code 23458919 to be part of this. Yes. Let us move to question number 4. Let us move to the question number 4. Shall we start question number 4? Yes. Get yourself ready. Question number 4 on the screen. Yes. I can see so many students watching me live. But do take part in the Menti quiz using the code which is mentioned on the top of the screen 23458919. Yes. The question is, the thermal efficiency of ideal Rankine cycle is less than the Carnot cycle operating between the same maximum and minimum temperature limits, because what is the reason behind that? 1 minute I had given you to get the correct answer. Rankine cycle and Carnot cycle. Why the efficiency of Carnot is more, Rankine cycle is having less efficiency. The options are given on the bottom of the screen. Select your answer. Can you see the options? Are the options visible to everyone? Is the time sufficient, or you need more time to recollect the concept? Is the time sufficient to everyone? Please do let me know through the comment section. You can talk to me through the comment box. Yes, so you should open the YouTube session as well as the Menti quiz at the same time in 2 different tabs. So you can talk to me through the comment section. Then I will come to know what are the challenges for getting the correct answer. Is the time insufficient? Are the options invisible to you? Option A is the correct answer, and 3 students had given the right answers. Yes. Why the thermal efficiency of ideal Rankine cycle? If I show you Rankine and Carnot, there is a phase change. These cycles are vapor power cycles. Rankine cycle is vapor power cycle. There is a phase change. Yes. So on TS diagram, if I draw both these, so point 1 is inlet to the turbine, then this is point 2, this is point 3, this is point 4. 1, 2, 3, 4 is Carnot cycle, and if I show you the Rankine cycle, then the Rankine cycle will be like this. 1, 2, 3 dash and 4 dash. So the heat addition, this is the maximum temperature TH, same maximum, and this is the minimum temperature TL. Why the Carnot cycle is having more efficiency? Because the heat addition is taking place at the constant temperature. So the mean temperature of heat addition, for heat addition, the mean temperature in Carnot cycle, which is TH, is greater than the mean temperature of heat addition in Rankine cycle. In Rankine cycle, the heat addition is taking place between 4 days and 1. So that is having lesser mean temperature. So that is the reason the thermal efficiency of Carnot is more than the thermal efficiency of Rankine. I hope you recall the concept. Options are not visible. Why? You can just log out. Physicum. You just log out of the Menti quiz and rejoin using the link or using the site www.menti.com, and then it will ask you the code use the code 2345819. Then you will get the options visible. The options are not visible because they are written in very small font. Is that the reason? So keep your device very near to your eyes so that you will be able to read. There are some challenges with the Menti quiz, but it will definitely be helping you to improve your speed as well as accuracy. Is this clear to everyone? So that is why heat addition does not take place at constant temperature in case of Rankine cycle, and the mean temperature of heat addition will be lesser in case of Rankine cycle, and that is why the thermal efficiency is less. I hope it is clear. So let us have the leaderboard now. Who was the fastest one? Ranveer had given the answer fastest, but still Nora Fatehi is the topper and Ranveer is on number 2. Let us move to the next one. Let us move to the next question. Question number 5th. Let us move to question number 5th, and those who have joined recently, do join the menti.com and use the code 23458919 to be part of this Menti quiz. Question number 5th on the screen. Yes, given you 1.5 minutes. The gas turbine power plant operates with air. Gamma is 1.4 between 1 bar and 20 bar. Very simple, very formula based question. The maximum thermal efficiency for the air is standard cycle. The options are in the bottom in percentage. The options are in terms of percentage. 30%, 36.7, 48.2 and 57.5. Yes. Waiting for your response. Quickly solve it using the calculator and get your answer. Thirty more seconds to go. Air can be treated as ideal gas. Which cycle gas turbine power plant is using? I hope you are busy with calculations and manage to get your answer, select your answer before the time ends. 5 more seconds to go. Select your answer quickly. Time is up. Oh my God. Not the great one. A gas turbine power plant is using the Brayton cycle, constant pressure cycle. The heat addition and heat rejection are constant pressure processes, and the P1 is equal to 1 bar, whereas P2 is equal to 20 bar. So we can say pressure ratio is P2 by P1, that is equal to 20. And what is the thermal efficiency of Brayton cycle? That is equal to 1 minus 1 upon Rp to the power gamma minus 1 by gamma. Everything is given. 1 minus 1 upon 20 to the power gamma minus 1. 1.4 minus 1, that is 0.4 divided by 1.4. Do the calculation, you will get the answer. 57.5 will be the correct answer. Yes. Yes. Good. Brayton cycle. The gas power plant. Brayton cycle. That is equal to 1 minus 1 upon T2 by T1 if you remember. And T2 by T1 is Rp to the power gamma minus 1 by gamma. Yes. Let us have the leaderboard. Fastest. KK was the fastest this time. But still, Nora Fateh is the topper. Yes. Are you guys enjoying? Let us move to the next one. Let us move to the next question. Question number 6. We are halfway now. There are 12 questions in total. Yes, very simple. Match the items in group 1 for their correctness with the corresponding appropriate terms given in group 2 and group 3. 1 minute only. Are you able to see the table? Group 1, pressure and heat. Group 2, path dependent and path independent quantity. Group 3 is X and Y, intensive and extensive. That is from the basic concept or basic terms used in the first chapter, the basic concept of thermodynamics. 20 more seconds to go. Your time is up. Oh my God. Great, great. Who was the one who had given the incorrect answer? Now, the pressure, if we talk about the pressure, yes. So, P for pressure. Pressure is path independent because it is a property. And which type of property it is? It does not depend on mass. So intensive property. Pressure is intensive property. So that is why P, this is 1 and this was X. If we talk about heat, heat is not a property, it is path dependent. That means Q and 2. Heat is path dependent. It is not a property, neither intensive nor extensive. So let us have the leaderboard. Let us have the leaderboard for this. Who was the fastest? Nora Fateh. Well done, well done. Give it up. Varun, you had also given the right answer. Sania had not opened the account yet. Good. Swagnik, Mifi, Kaushal. Well done, guys. Keep it up. Let us move to the next one. Next question. I hope you guys are enjoying. Those who are here for the first time or those who have joined now only, please. Acha, Sagnik, welcome Sagnik. I was waiting for you. So do open the menti.com and use the code which is given on the screen 23458919. I hope remaining the rest of the quiz you will be able to cope up with the other students who had started, who had joined from the very beginning. Let us move to the next question, question number 7. So get ready for question number 7. Yes. One minute only for question number 7. A heat pump extracts heat energy from the cold reservoir and supplies the same amount of energy to the hot reservoir. Which of the following statements holds correct? There are 4 options on the bottom of the screen. You need to select the correct answer as per your understanding. The first option is this process violates both the first and second law. The option B is violates first law but does not violate the second law. Option C is violates the second law but does not violate the first one. Option D is neither violates first nor violates second law of thermodynamics. 20 more seconds to go. We had already discussed about that. So those who are not able to recollect the concept, do revise again and again the same concept. Keep on revising again and again so that you will be able to recall the concept within the limited time frame. Your time is up. Time कम पड़ गया लगता है. क्या हुआ? What happened? Now, if we see, look, a heat pump. What is a heat pump? It extracts the energy or heat from low temperature reservoir. Let us say this is Q2 and giving to the high temperature reservoir. This is heat pump. It is a work consuming cyclic device, anti-clockwise cycle. So the question says if Q2 is equal to Q1, the heat pump extracts heat energy from the cold reservoir. This is the cold one and this is the hot one. So Q2 is equal to Q1. Then what about if we see the first law of thermodynamics for the system? So Q2 is equal to Q1. It means the first law is not getting violated. The energy in is equal to energy out. So W will be equal to 0 in that case. So it is not violating the first law, but yes, definitely it is violating the second law. Which second law? The Clausius statement of second law of thermodynamics. What is the Clausius statement of second law of thermodynamics? So that is also you need to take care, Nora Fateh. The second law of thermodynamics or the Clausius statement of second law of thermodynamics says that it is impossible to develop a cyclic device in which heat flows from low temperature to high temperature reservoir without any external work. We need to provide an external work if we want the heat to flow from the cold reservoir to the hot reservoir. So that is violating the second law. Violates second law, or more specifically the Clausius statement of second law of thermodynamics. All right, let us have the leaderboard now. Let us have the leaderboard. Good. KK is the fastest one. Yes, KK, keep it up. You can become the topper. So let us move to the next one. Question number 8. Without wasting much time, let me present you the question number 8. The Carnot cycle is not used in vapor power cycles. What is the reason? Assertion is Carnot cycle is not used in vapor power cycle. The reason is pumping of a two-phase mixture is difficult. 40 seconds to select. If both assertion and reason are correct and the reason is the correct explanation for assertion, option A. If assertion is correct but the reason is also true but the reason is not the correct explanation, then option B. If assertion is correct and the reason is false, option C. And assertion and reason both are false, option D. 20 more seconds to go. Ten seconds to get your answer, assertion and reason. Your time is up. Option A is actually the correct answer. Look how. If we draw the Carnot cycle on TS curve, this is how the Carnot cycle will be drawn. 1, 2, 3, 4. The problem with the Carnot cycle is point 3 is in wet region. It is a mixture of liquid and vapor or water and vapor. Point 3 is in wet region, which is a mixture of. So it is very difficult to design a compressor which can handle or which can deal with the liquid and vapor mixture. And that is the reason Carnot cycle is not used in vapor power plants. Which cycle is used? It is the Rankine cycle which is used, which where the pump is used to compress or for the pumping of water, and then heat addition will convert water into vapor. That is why the Carnot cycle is not preferred and the Rankine cycle is used in vapor power plant or vapor power cycle. Right? So let us have the leaderboard. Who was the fastest? Nora Fateh. Great. Let us move to the next one. Question number 9. Let us move to the question number 9. Yes. Are you guys enjoying? Match the column, list 1 with list 2. Very simple but beautiful. Conceptual question. Everyone, please take part. KP, LQ, MR, NS. I hope you will be able to understand the options A, B, C, D. इसके लिए 1 मिनट कम है, isn't it? Concentrate and get your answer. Fifteen more seconds to go. Three, two, one. That's it. Time up. What happened? Oh, actually, I had not selected the correct answer. That is why. Now, I forgot to select, because if you are a little uncomfortable with the quiz, Menti quiz, don't worry, because we will be having these type of Menti quizzes very often. It is also first time for me as well. It is also first time for me to take this Menti quiz. That is why I am also a little bit uncomfortable. But yes, we will keep on having these type of session, because that will calculate your accuracy as well as your time management even. So it is very important for you to recollect the things within the limited time frame. So let me put the options. How was that? So the K was jet engine. Can we go back? Let me see if we can go back. Can we go back? No. Okay, so jet engine. No, we cannot go back actually. Yes, P was jet engine. K was jet engine. Jet engine is an open system. Open system. Jet engine is an open system or control volume. Control volume. So K will be matched with Q. KQ. And L was water in a sealed container. Water in sealed container. That is closed system or control mass. So for that P. Then M was internal energy. That is the property. And it is independent of mass. It is depending on mass. Energy always depend on mass. So extensive property, internal energy is extensive property. all the energy terms depend on mass. So extensive property. So that was S. And N was specific entropy. Specific properties are intensive. Specific internal energy is intensive, but internal energy is extensive property. That is why specific entropy is also a property, but is independent of mass, because specific entropy is entropy per unit mass. So that is why it is independent of mass. So R. So K, Q, L, P, M, R, M, S, and N, R. Option. This should have been the correct answer. Those who have got option C, they should have got the marks, right? So it was my mistake. I could not select the correct answer. I forgot to select the right answer. Option C is the correct answer. Is this clear to everyone? Let us move to the next one. Let us move to the next question. Question number 10. Question number 10 on the screen. Those who are coming live now only, do join menti.com and use the code 23458919. The mass, internal energy, pressure and volume of a system are given 10 kg, 100 kilojoule, 1 bar and 1 meter cube. The value of a specific enthalpy is. Select your answer. Thirty more seconds to go. Write all the given parameters in your notebook and then find out the specific enthalpy, that is intensive property. Fifteen more seconds. 3, 2, 1, and time is up. Not 20 kilojoule per kg will be the correct answer. Look, what are the parameters given? Mass is given. Mass is given. Mass is given as 10 kg. Internal energy 100 kilojoule. Pressure 1 bar, we can say 100 kilopascal, 1 bar is 100 kilopascal, and volume is 1 meter cube. These are given. The question is to find out the specific enthalpy. Enthalpy is actually a combination property. What is enthalpy? That is internal energy plus flow energy, U plus PV. So find out the total enthalpy, that is extensive property. U is 100 kilojoule plus pressure you should take in kilopascal and volume in meter cube, then it will give you kilojoule. 100 into 1. So the total enthalpy is 200 kilojoule, but the question is about small h, specific enthalpy per unit mass, that is 200 divided by 20. Sorry, 200 divided by 10. That is 20 kilojoule per kg. Option B is the correct answer. Let us have the leaderboard now. Good. All right. You can check your score and let us move to the next one. Let us move to the next question. 11th question, second last question for the day. Again numerical from the heat pump. The question is to find out COP. A heat pump extracts heat at 100 kilowatt from a low temperature reservoir and delivers heat at 160 kilowatt to a high temperature reservoir. What will be the COP? Very simple, yet beautiful. Given you 1.5 minutes, do your calculation. I want everyone to get the correct answer. For this question at least, I want everyone to get the correct one. I have already discussed in the second law of thermodynamics, I have already talked about the heat engine, heat pump and refrigerator. So those who have missed the session, they can watch the YouTube session once again. You can just search me, Chandrashekhar, on the YouTube, BYJU'S YouTube channel. And the series is Mastering Gate Concepts for 2023. What is that? Dad's princess. 20 more seconds to go. They are actually options A, B, C and D. These are 4 options. You have to select your option as per your calculation. Your time is up. D is the right answer. Still people are there who could not get the correct answer. See, if we talk about the heat pump, desired effect is Q1. This is Q2 and this is work. There is a difference between heat pump and refrigerator. Heat pump extract heat at 100 kilowatt. Q2 that is equal to 100 kilowatt. From a low temperature reservoir, this is the low temperature reservoir, cold reservoir. This is the hot reservoir. And delivers heat at 160 kilowatt to a high temperature reservoir. This is 160 kilowatt, Q1 dot. We can find out W dot from the energy balance equation, first law of thermodynamics. W dot will come out to be, what will be W? It will be 60 kilowatt, isn't it? And what is COP for the heat pump? Desired output, that is Q1 upon W dot. Q1 is 160 divided by 60. So it is 16 by 6 or 8 by 3. 8 by 3 will be the correct answer. 2.67. 8 by 3 or 2.67. Let us have the leaderboard now. And the last question for the day, I hope you have enjoyed it. Do revise the concept if you are not comfortable with the concept. Swagnik. Okay, it is, who is he? Swagnik Chatterjee. So let us move to the last one and then we will end our session. And I want everyone to get the correct answer for the last one. Yes. Get ready for the last one. For helium, specific heat at constant pressure is given. Molecular mass or molar mass is also given. The specific heat at constant volume will be how much? I want everyone to get the correct answer for the last time. Then we will be meeting again for the next subject, fluid mechanics. But after thermodynamics, strength of materials will be going to be started. So keep on following this series, that is for GATE 2023 aspirants, which is very, very important for your GATE examination preparation. Time is up. And oh my goodness, C will be the correct answer. Na, आया नहीं आपको. Do you know Cp minus Cv is equal to R? R is the specific gas constant which can be written as R bar by M. M is the molecular mass. Cp is given as 5.19 minus Cv is equal to R bar is 8.314 kilojoule per kilomole Kelvin divided by 4, that is kilogram per kilomole. So this kilomole getting cancelled out. So Cv is equal to 5.19 minus 8.314 divided by 4. That will give you the answer in kilojoule per kg Kelvin, isn't it? So that will give you 3.11. Let us have the final leaderboard and the one who had got the fastest correct answer. Who was the fastest one this time? Yes. So that is all for the session. I hope you guys have enjoyed it and you guys have learned to improve your speed. If you are not able to get the right answer within the limited time frame, we will keep on having these type of sessions to improve your understanding about the subject, to make you comfortable with your preparation. We are here to help you out. Hi, Sagnik. Yes, Sagnik had given the fastest answer for this question. So that is all. Nora Fateh, well done. Congratulations. And those who have not been able to, those who are not satisfied with their performance, try to improve your performance by revising the concept again and again and by solving more and more numericals on your own. That is all from my side. Enjoy, take care, have a good night, and keep preparing with BYJU'S Exam Prep. Thank you very much. Stay safe, stay motivated, and all the very best for your future ahead. Thank you guys. Thank you for being part of this session, and Jai Hind.